let's go with number right on the assessment. On the ass. Let's go assess. Keep it G-rated. That's great. So here's the control group again. And then here are, rather than sugar and vegetarian, we'll do media multitaskers. Media multitaskers. And I'll have a quiz. I'm going to design a quiz for you guys on this, so it's a little less seat of the pants. I had this idea right before class started to bring in a quiz for this. So if this is the control group, which of these two are the researchers like secretly hoping for if they want to prove their point? They want blue. Now, obviously, it's to the right. Maybe they want it to the left. That's what Elizabeth was saying. But the idea is they want them separated, correct? So when you go into the study, are they going to say something like this? Are they going to say something like, okay, here is the average of the control group. We predict that the average of the experimental group is going to be this much different. How hard would that be to do? Before you've collected any data whatsoever. How hard would that be, right? I mean, your gut's saying that they should be different, right? But what number do you assign to it? I can't, right, Anna, I'm with you. I can't think of one. So you know what very clever researchers often do? They start by making this assumption. They assume that the blue and the green are going to have the same average. Start by assuming they are no different, and then what happens, hopefully, in the course of the study? What happens? Go ahead, be brave.
Prove yourself wrong.
Yes, you prove. Say that again.
Prove yourself wrong.
Jake, you prove yourself wrong. That seems stupid, right? I shouldn't say it seems stupid. It seems counterintuitive. Let's use a better word. It seems counterintuitive, but actually, it's perfectly intuitive because it takes the onus of you supplying a number away. See. That's a cool little juice harp. If you put it right with the control group, you don't have to supply some alternate value, right? All you've got to do is, I'm going to assume it's here, and then, oh crap, look what happened. It moved away. You see what I'm saying? You almost want that contradiction in terms, because the contradiction in terms will actually get you where you wanted to be in the first place. Number one. And number two, it gets you off the hook from having to say, oh yeah, well the control group averaged 0, you're going to average 4. What if it's 5? Then you're wrong. Both, you're wrong. It changed, but it changed more or less than you said it would. So why not just say, I assume they're here, and fingers behind the back, and this is statistical good, by the way. Not Truman Show like marriage good, but this is actually statistical good. Like, I hope it's going to change. And let's see. Let the data speak to you, huh? Is that fair? When you ran that quiz yesterday with the F9 button, when you ran that quiz, who said 95% was going to show up? I mean, we've been talking about it, right? But it just showed up on its own. Why? Because it's data. Because it's data. That's what it does. Let it do what it's going to do, and then you just metric it. Pretty badass, huh? This is kind of the scientific method.